6, 5, 4, 3, 2, 1.
Assalamualaikum and hi everyone. Here I am, ADAWIYAH NATASHA binti NAZRI with number matric D202211025141 from Group A. Today, I will explain about system structure.
Semua jenis komputer mempunyai struktur dan fungsi asas komputer yang sama dan mengikut operasi asas. Operasi ini bertanggungjawab untuk menukar raw input data kepada beberapa maklumat yang berguna untuk pengguna komputer. Struktur asas ini termasuk unit input, CPU iaitu unit pemprosesan pusat dan unit output. Seterusnya, kita akan melihat elemen yang ada dalam system structure ini. Whereas system structure refer to the arrangement of interconnected computers that work together to perform tasks. This involve three main steps, which is receiving input, processing input, and producing output. Dalam proses receiving input, sistem akan menerima data atau arahan daripada user atau sistem lain. Seterusnya, processing input, sistem akan proses data yang telah diterima mengikut spesifikasi arahan atau programs. Step yang seterusnya ialah producing output. Sistem akan generate dan mengeluarkan maklumat atau keputusan berdasarkan proses yang dilakukan. Next, we will go through about types of system structures in operating system. First, we will go through about monolithic kernel. In a monolithic kernel, the entire operating system runs as a single program in a kernel mode. It includes all the necessary services such as file management, memory management, device drivers, and system calls within one large block of code. For example, that I could give is traditional Unix and early version of Linux. Here I give two pros for monolithic kernel, which is first speed, high performance due to direct communication within the kernel. The second one is simplicity, which is simplified access to all resources, which can lead to faster operation. However, there is two cons for monolithic kernel, which is first, unstable. Stability issues as a bug in one part of the kernel can crash the entire system. The second one is insecure. Security risks since all parts of the kernel have unrestricted access to the system. Next, we will go through about microkernel. A microkernel architecture divides the operating system into small separate processes. The core functions such as basic memory management, process scheduling, and inter-process communication run in the kernel, while other services like device drivers, file system, and network protocol run in user space. For example, QNX, Minix, and L4. Same as monolithic kernel, microkernel have two pros and two cons. First, we go through about pros first. First is more stable. Why I said that? Because microkernel improve stability and security since most services run in user mode. And another pros for microkernel is easier updates. Easier to modify or replace individual services without affecting the entire system. The con for microkernel first is lower potential performance overhead due to frequent context switches and communication between kernel and user space. The second one is complex. Microkernel is more complex system design and debugging. Next, we will go through about layered system. The operating system is divided into a numbers of layers or levels, each built on top of lower ones. Each layer only interacts with the adjacent layers. The example that I will give is THE, which is Technisches Hochschulsystem Schools and Hoven operating system. The pros of layered system is easier to understand because simplified design and debugging due to clear separation of concern. The next one is independent layers, which is each layer can be developed and tested independently. The con for layered system is first less efficient because potential inefficiency as each layer adds overhead. The second one is rigid structure. Rigid structure may lead to difficulty in designing cross-layer functionalities. The fourth one is modular kernel. This architecture combines aspects of monolithic and microkernel designs. The core kernel is kept small and additional functionalities are implemented as modules that can be dynamically loaded and unloaded as needed. For example, modern version of Linux. The pros for modular kernel, first is flexibility. Flexibility in adding or removing functionalities. The second one is better performance, which is potentially better performance than microkernel due to fewer context switches. The con for modular kernel, first is complex management, which is complexity in managing modulars and ensuring their compatibility. The second one is security risk, potential security risk if modulars are not properly isolated. The last one is exokernel. An exokernel architecture is designed to give application more control over the hardware by minimizing the abstraction layer between hardware and software. The kernel provides basic resource management while higher level abstraction are implemented at the application levels. For example, MIT exokernel. The pros for exokernel, first is high performance. High performance and flexibility since application can tailor resource management to their specific needs. The second one is simplicity in kernel. Minimalist design reduce kernel complexity. The cons for exokernel is first difficult for developers, which is increased complexity in application development as application must handle more lower details. The second one is potential security issues. Potential security issues as application have more direct access to hardware. The last part of element that we will go through about system structure is comparison of system structure. It's contain 4 elements, which is performance, security, scalability, and complexity. First is performance. Monolithic kernel often offer better performance due to fewer context switches and direct communication. However, microkernels may suffer from performance overhead due to frequent inter-process communication. The second one is security. Microkernels typically offer better security since most services run in user mode, reducing the risk of system-wide crashes. However, monolithic kernel can be less secure because a flaw in any parts of the kernel can compromise the entire system. The third one is scalability. Modular kernel and microkernel can be more easily scaled and adapted to different hardware and usage scenarios. However, monolithic kernel may be less flexible in adapting to new requirements without extensive modification. The fourth one is complexity. Monolithic kernels are simpler in terms of design but can become complex to maintain as they grow. However, microkernels and modular kernels are more complex to design but easier to maintain and extend. Kesimpulannya, sistem pengendalian iaitu OS membolehkan pengguna berinteraksi dengan perkakasan komputer dan mempunyai pelbagai struktur seperti monolithic kernel, microkernel, layered system, modular kernel, exokernel, and virtual machines. Setiap struktur mempunyai kelebihan dan kekurangan dari segi prestasi, keselamatan, kebolehskalaan dan kerumitan. Contohnya, monolithic kernel menawarkan prestasi tinggi tetapi sukar diuruskan, manakala microkernel lebih selamat tetapi mungkin kurang berprestasi. Secara keseluruhan, perkembangan dalam struktur-struktur ini telah menjadikan sistem pengendalian lebih baik dan efisien dari masa ke masa. Sekian, terima kasih.